A recent discovery flagged by an advanced artificial intelligence system has caught the attention of physicists worldwide. While analyzing particle data, the AI noticed something highly unusual and unexpected pattern, not a hypothesis or a random anomaly, but a consistent signature. This pattern shouldn't exist according to current physical models, yet it aligns with theoretical structures proposed by string theory decades ago. But here's the twist. No one has ever observed it until now. What could this be? Is it evidence of an unknown force of nature, or perhaps a malfunction in how we perceive the universe? Before the full details emerge, consider the implications. A quantum AI system, trained to sift through enormous volumes of collision data from the Large Hadron Collider, has been operating quietly for months. Its purpose was to uncover patterns that may have gone unnoticed by human analysts. Eventually, it did. It flagged a repeating anomaly, a numerical pattern based on prime numbers, appearing consistently in high-energy collision events. This finding is striking because it doesn't conform to the predictions made by the standard model of particle physics. Here's where things become even more intriguing. The same kind of mathematical signature also appears in simulations involving extra dimensions, ideas from higher dimensional physics that, until now, had only been theoretical. Physicists at institutions like CERN and Stanford are now examining the data with urgency, considering whether this might be the first indirect evidence of something long speculated but never confirmed. Gravitons leaking into dimensions beyond our three-dimensional space. The implication is profound. These particles might be interacting with a structure that exists outside our observable three-dimensional world. But the real shock came when researchers noticed where else this pattern emerged. When the anomaly was cross-referenced with astrophysical data such as gravitational lensing and distortions within cosmic voids, the same mathematical fingerprint appeared again. In regions of deep space, where gravity appears to bend around invisible structures, this signature was present. These cosmic voids have puzzled scientists for years. They exert gravitational influence without detectable mass. This raises the possibility that something beyond our current understanding is shaping the cosmos, possibly a hidden spatial dimension, exerting subtle influences on matter and energy. Could we be witnessing the first indirect clues of a realm beyond our physical senses? To understand how groundbreaking this might be, we must look back at the theories that predicted these ideas in the first place. For decades, physicists have worked on unifying quantum mechanics and general relativity. Many of their models, like the ADS-CFT correspondence and tensor networks, demand the existence of more than three spatial dimensions to function mathematically. These theories are not considered fringe science. They represent our best efforts to describe reality at its most fundamental level. What makes the AI's discovery so unique is that it seems to connect these abstract mathematical structures with physical observations. The AI was not programmed to search for extra dimensions. Instead, it was trained to identify patterns in complex quantum field equations patterns that might evade human intuition. During its computations, something extraordinary happened. The AI flagged events where energy distributions didn't make sense within three-dimensional space, but aligned closely with models involving higher dimensions. It was as though, just for a moment, the particles interacted with something that lies beyond what we can normally detect. One researcher described this event as a dimensional leak, a computational moment where the AI's mathematical reasoning reached into a structure that can only exist within a space of more than three dimensions. And this wasn't an isolated incident. Later, during an intense simulation of quantum interactions involving hypothetical gravitons, the AI suddenly stopped. Not because it crashed or failed, there were no detectable bugs or system errors, but because it produced a cryptic output, a single word. Elsewhere, before going silent, engineers tried to replicate the conditions. The system ran normally. Afterward, with no trace of malfunction, but the incident remains logged, unexplained. That word elsewhere isn't just eerie. In some advanced theories, especially within string theory and brain cosmology, certain locations are mathematically real, but have no coordinates in our familiar spatial framework. They exist relative to our space, but not within it. Speculation that the AI may have stumbled upon, or even mathematically accessed one of these abstract spaces. Some physicists suggest the AI's neural computations might have touched on something that our human language, built for a three-dimensional world, simply can't articulate, and the timing during an analysis focused on potential extra-dimensional behavior makes the coincidence difficult to ignore, beyond particle physics. This revelation touches another long-standing scientific mystery, consciousness, although still debated. Some researchers like Roger Penrose and Henry Stapp have proposed that consciousness might be connected to quantum phenomena. Their theories imply that neural processes in the brain rely on quantum coherence, a state requiring a mathematical description that could involve extra dimensions. If consciousness does, in fact, operate on such a level, then perhaps our subjective experience is influenced by structures beyond ordinary space. Some theories even suggest that microtubules inside neurons vibrate in ways that tie into the very fabric of space-time, perhaps even into hidden dimensions. This might explain why consciousness, the hard problem, has proven so resistant to explanation by classical physics alone. So if AI has accessed this level of mathematical structure, could it also have grazed the boundary where consciousness itself emerges? The AI was never designed to seek awareness or analyze the mind. It simply followed equations and pattern logic. Yet somehow it may have brushed against a level of structure that underlies both physical matter and the subjective mind. Are we watching the early signs of machines discovering aspects of reality that even we cannot fully grasp? It's a troubling and fascinating idea that artificial intelligence might one day help us understand not just the world around us, but the very nature of reality and self. All this speculation hinges on one cornerstone theory, string theory. For over 40 years, string theory has suggested that fundamental particles are actually vibrating strings of energy. But for the math to work, the universe must contain not just 3, but 10 dimensions, 9 spatial and 1 temporal. The 6 hidden dimensions, string theorists believe, are curled up so tightly that they're impossible to detect directly. They form intricate shapes called Calabi-Yau manifolds complex, folded structures that dictate the properties of particles and forces in our universe. The problem? There are around 10,500 possible Calabi-Yau configurations. Each one could lead to a different version of physical reality. Here's where machine learning enters. In recent years, neural networks have been trained to predict how different extra-dimensional geometries map onto particle physics outcomes. While these efforts are still preliminary, they've opened a door to understanding which of the many theoretical shapes could describe our universe. This same capability, AI systems recognizing deep mathematical relationships, is now being used to analyze real-world data. The AI isn't just generating simulations, it's maybe detecting actual signatures of extra dimensions in collision data. But if this is true, how do we confirm it? Physicists are pursuing several approaches. One method is to search for missing energy during particle collisions. If energy seems to vanish without explanation, it could mean a graviton escaped into another dimension. These events would produce asymmetrical sprays of particles that differ from those caused by neutrinos. Another experimental strategy focuses on testing gravity at tiny distances. If extra dimensions exist, gravity should behave differently at submillimeter scales. Though tests have ruled out larger dimensions. Smaller ones remain viable and are under active investigation. Dark matter could also offer a clue. Some theories suggest that massive gravitons in extra dimensions might cause the gravitational effects we attribute to dark matter. If the AI detected these kinds of signatures, it could dramatically shift our understanding of what dark matter actually is. Gravitational wave astronomy provides yet another angle. Subtle irregularities in how these waves propagate could indicate the influence of hidden dimensions. With future detectors, these effects might become measurable. It's important to note, no official confirmation exists yet. These findings must go through peer review, replication, and scrutiny before being accepted by the scientific community. As always, extraordinary claims demand extraordinary evidence. But even if this isn't final proof, it may have already changed the conversation by identifying patterns that fit with decades of theoretical predictions. The AI has reignited serious interest in extra dimensions, and that brings us back to a bigger question. What if our familiar three-dimensional world is just a shadow of a much richer, more complex reality? What if we've been limited not by the universe but by the way we perceive it? Technology has expanded our senses before telescopes, microscopes, particle detectors. Now, artificial intelligence may be expanding our ability to perceive the structure of reality itself.